Okay, good morning class. This is lab 4-2, voltmeter loading. The purpose of this lab would be to obtain accurate measurements using an analog multimeter. In this case, we're going to use it to measure voltage. Voltmeter loading is something that we have to pay attention to, especially obviously when we use analog meters. Because of their sensitivity, their ohms per volt rating, sometimes they can conflict with the circuit that we are intending to measure. And what this lab is going to demonstrate is when we have low resistance loads like we have up here. We've got two 100 watt light bulbs connected up in series to a 50 volt DC supply. When we use our analog multimeter to measure the voltage drops across those, you're not going to see very much difference between the analog and the digital meter that we're going to use to compare. However, when we put some 2.2 megohm resistors in series with the same 50 volt DC source, you're going to see that the analog multimeter here is going to, I guess, augment the circuit or change the circuit a little bit. In other words, it's going to create a combination circuit, okay? And that's based on the ohms per volt rating of this multimeter. Now this multimeter in the DC scale, well, and AC scale, it has an ohms per volt rating of 20,000 ohms per volt, okay? So on the 50 volt scale, we're going to see a ohms per volt sensitivity of 1 million volts. Or sorry, 1 million ohms per volt, okay? That's significant because when we put it in parallel with a 2.2 megohm, yeah, that's right. When we put it in parallel with a 2.2 megohm, you're going to see that the voltage is not going to be equally split, that we're going to see some differences. So let's explore that right now. What I'm going to do is I've already wired this up to the 100 watt light bulbs here. These are the low resistance bulbs that they anticipate. The fluke meter that I have down here is simply here to measure the output voltage that we have at the source. I've got another fluke meter here that I will hook up to compare the results that we see. Now we will also see a little bit of a difference when we get into the high sensitivity ones or high resistance loads due to the sensitivity of that fluke meter, but let's just explore it. So I'm going to power up. I'm going to adjust my voltage here up to the 50 volts that they ask us to do in DC. Just see if we can take this right up there. Oh, we're a bit high now. Let's go a little under 50 if we can. It's touchy. Okay, we're 50.1. All right, so now if I measured my voltage drop across each of these loads, and I'll just zoom in on the meters themselves if I can. Okay, so this meter here, as I measure across the bulb in correct polarity, we're going to see about 25 volts there, and same thing on the other one, roughly 25 volts. Okay, so we should see when this guy is on the DC range like it is, this analog multimeter should show the same, and what I'm going to do is I'm just going to focus this in a little bit closer on that multimeter if I can, so that we get, because that's really the whole reason for us doing this lab, is to get that multimeter reading, and it's tough to see that when you guys aren't here. Okay, so I'm just going to measure across the entire both loads there as I get my leads untangled. Something like this. There, that should spread them out reasonably speaking. Okay, make sure that I have them connected in right polarity, otherwise that meter will sweep downscale. So you can see here, and I'll just leave that connected for a minute, that needle is going to sweep all the way to the 50 volts at the far end. Okay, let's move these test leads out of the way so you can see it a bit better. All right, so there's the 50 volts. Now, going across one load, about half the needle sweep, so 25, and then going across the other load here, oopsies, come down. There's the 25 again. Okay, so I'm going to power down. I'm going to leave that source exactly where it was, and all I'm going to do now is I'm just going to change my low resistance loads to my high resistance loads, okay? So all I've done is I've wired up these guys, these 2.2 meg ohms in series. So we've got the negative coming here, going through that resistor, jumpered over through that resistor, and then back to positive. So that's all I'm going to do here. Okay, so now we're going to take the same measurements that we had before, if I can just get it so that we don't have these leads crossing in front of what we need to see. Okay, so now we can zoom in on what's going to happen here. So remember that my fluke meter here, it will differ a little bit. It's not going to see exactly 25 and 25. Okay, so we're going to power that up. Measure the source voltage again, just to prove that it's there. So we're at about 51, sorry, wrong polarity. 51 there, so let's dial that back just a little bit. And then we're gonna go load to load. On the fluke, we're about 22, and that's the fluke sensitivity that's taking an impact in there. Okay, and 22 on this guy. So it's the same. Little insignificant change there, but you're going to see it drastically increase in this situation here. So remember, this is about 1 million ohms per volt in sensitivity. So we're going to, when we connect it up on one side of this guy, you're going to see that this is we expect it to be around the 22 or 23 or 24 volt mark. However, it's not going to be. It is sitting at 12 volts. Okay, so if I see 12 volts there, then I would anticipate the other load must be seeing 38-ish, but it's not. It's seeing 12 there. However, if we went across both loads, you can see that we definitely still have the 50 there. Okay, so what that is that's the resistance of this meter, okay, being put in parallel. Or I guess we got 1 million ohms being put in parallel with a 2.2 meg ohm source or resistance over here. So it's changing that combination, or changing it into a combination circuit. We'll explore this at greater length in the Learning Hub when we discuss how the circuit works and why we saw the readings that we saw. But for right now, if I zoom out a little bit, sorry, you're just getting my mouth there, we'll just zoom you back. Okay, for right now, that's the end of Lab 4-2, and we'll discuss it in the Learning Hub. All right, thank you very much.